Okay, in video number 21 of Theory of Computation, I showed how to give a DFA for the complement of the language if the DFA for the language is known. But it has a issue of background noise. If you are watching video, just watch video 21. Okay, try to understand and make notes. And if it's okay, then okay. But if you cannot understand because of the noise, then watch this video also. Anyways, let's say this is a language L. Okay, is regular. L is regular. Okay, L is regular, and M is the DFA for it, and M is the DFA for it. L is regular and M is the DFA for it. That is, language of M is equal to L. Right? Now, this M, a typical M would be, any DFA would be something like this. Right? In any M, you are going to get a set of states. Let's say that is Q0, Q1, Q2, so on, so on. Let's say Qn. So M has, say, n states. Now you know that in DFA, if this is your summation star, 1 minute. If this is summation star, okay, if this is summation star, means set of all possible strings, over summation, right? There's going to be some moves between the states, transitions between the states. I'm giving a dotted sign because there may be a transition or may not be a transition, and then over a symbol. This is what any typical DFA is like. Let's say M is the DFA for L. M is the DFA for L. Now, and M has n states. Those states are Q0, Q1, Q2, Q0, Q1, Q2, so on, Qn. Now you know that the states of the DFA partitions the summation star. We have seen that in the introduction to DFA, the very first video, short introduction to DFA, something like that, or introduction to deterministic finite automata. Each and every state partitions the summation star, partitions the sigma star. What do we mean by that? It means that each and every string that is in it, each and every string that is in summation star, when you fed it to any DFA, then it was going to end up to any of the state. Okay, let's say this string S1, this is S2, this is S3. Okay, so let's say these strings end up, let's say S1, S2, S3, on Q0, S1, S2 and S3. These are the strings that will always end up at Q0. Similarly, at Q1, there will be some set of strings which will always end up at Q1. This is what it is. The states of DFA partitions the summation star. By partitions, I mean each state represents a set of strings that will end up at that state. Each state represents a set of strings that will end up at that state. So let's say Q0 represents set of strings that will end up at Q1. Similarly, Q2 represents set of strings that will end up at Q2. That will end up at Q2. And what is the language of the machine? Language of machine is set of strings that will end up to the final states. That will end up to the final states. Okay. Now, if I say that in it you have one state which is final. Let's say this is your Q, and let's say F is the set of final states, and you have QF1. Okay, 1 minute. F is the set of final states. Then you have QI plus 1, so on. QI plus 1 and QI plus 2. These states are the final states. So there will be set of strings that will end up at QI, set of strings that will end up at QI plus 1, set of strings that will end up at QI plus 2. So L of M is set of strings that will end up at the final state. So there will be, that is, what is L of M? L of M belongs to all those strings that will end up at Q1, QI or QI plus 1 or QI plus 2. Okay. You have a machine M. Okay, there is going to be one initial state Q0, and then Q1, Q2, Q3, and then you may have moves between them. Okay, so possible moves between them, whatever combination of possible transitions are there. I don't care right now about that. If language of M is equal to L, now consider a DFA M dash. Consider a DFA M dash obtained by M by making final states as non-final and non-final states as final. Let's say you make a state. So if M has set of states as Q1, Q2, set of states as Q0, Q1, so on, Qn, and the final states as Qi, Qi plus 1 and Qi plus 2. Okay, so what I am doing is M dash, the transitions are same. This whole thing is same. So what it's saying is this, that you use the same DFA. Okay. Same states, same transitions, same states, same transitions. But your final states are, but your non-final states are Qi plus 1 and Qi plus 2. and final states are Q minus Qi, Qi plus 1, Qi plus 2. Okay. So what is the language of M dash? This is what you should be asking. What is the language of M dash? L of M dash is equal to L dash. The language of M dash is equal to set of all strings that will end up in states not in Qi, Qi plus 1 and Qi plus 2. So all those strings comprise what? It comprises sigma star minus n. So that's it. So from here you get this conclusion that if L is a regular language and M is a DFA such that L of M is equal to L, then L dash is also a regular language and DFA for L dash can be obtained from M by making the final state of M as non-final and non-final state of M as final. Okay, thank you very much.